This is Algebra Lesson 8.5, Scientific Notation. Scientific notation is a method of writing that allows us to write larger or smaller numbers in a more concise fashion. And the way that it looks is it's always going to be a number. We'll go with A. And A has to be between 1 and 10. So it has to be 1 up to 10. Basically, it can only be a single digit, a ones place digit, and then we would write that number times 10 to the power of k. K is representing the place value, and place value is the proper way to say number of numbers, number of digits that you would see in the number. Basically, it's going to be like the number of places that you move your decimal point. So if you have a really big number, you'd have to move your decimal, or if you have a really small number, you'd want to move your decimal so that you have exactly one number, one digit in front of your decimal. The number of digits behind don't necessarily matter, but we're moving our decimal so that there's exactly one digit, and that's what I'm trying to represent here. A single digit, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. Can't be a 0, can't be a 10, can't be an 11 in front of the decimal. And however far we have to move the decimal to make that happen would be the power. If you move your decimal to the left, you're going to have a positive power. And if you end up moving your decimal to the right, you will have a negative power. Okay, so that's a lot of words. I think it's much easier if you see it in action. So the first example here gives me a number. That number is 6,849,457. And if I want to put that number in scientific notation, I have to move the decimal of this number so that there is exactly one number in front of that decimal. So if you're looking at it now and saying, well, I don't even see a decimal. Well, when there's no decimal, it's implied at the back of the number. So I'm going to take that decimal and I'm going to move it so that there is exactly one digit in front of the decimal. So that is 1, 2, 3, 4, 5, 6 spaces. So if I had to move my decimal 6 spaces to the left, that means I'm going to have a positive 6 power. So I'm going to go with 6.849457 times 10 to the 6. So times 10 to the 6 is representing 6 place values that we had to move that decimal. I don't necessarily need you to write all of those decimals. Maybe 6.8 times 10 to the 6 would be sufficient. It depends on if the instructions are asking you to give the exact value or a rounded value. So that's up to that. Letter B. I have, let's see if I can get this right. Tenths, hundreds, thousands, 10,000s, 100,000s, millions. 456 millionths? I think that's right. So right now we can see our decimal here. We need to move it 1, 2, 3, 4 spaces. We're moving till we have exactly one number in front of that decimal place. 4.56 times 10 to the, we moved it 4 spaces to the right, so that is a negative 4. And the last one, negative 5. No decimal means the decimal's at the back of the number. Right now I have exactly one digit in front of the decimal. So this is already in the proper format. How many spaces did I move that decimal? Well, I moved it 0 spaces. And if you think back to what we talked about on lesson 1, anything to the power of 0 is just the invisible 1. So this is really negative 5 times 1, which is still just negative 5. But to be in proper notation, we want to see that times 10 to the something, otherwise it's in standard notation, which we're going to talk about next. So if I wanted to go back from scientific notation into standard notation, we're going to move our decimal backwards compared to how we just moved it. So a positive power means move your decimal back to the right, and a negative power means move your decimal to the left. Okay? So 9.123, I'm going to write 9.123. I need to move my decimal 5 places. So starting here, 1, 2, 3, 4, 5. And these empty spaces here get filled in with zeros. So I'm going to get rid of this so I can try to figure out what this number is. 3 spaces, that is 912,300. Letter B, I have a 1.1. My decimal is here, and I need to move 3 spaces to the left. 1, 2, 3. My decimal now is here. I fill in these spaces with zeros. If you want to, you can have that leading 0. That's technical proper notation. But I don't want that leading 0 to confuse you, so I just moved it because it was close to answer A. But so this is tenths, hundredths, thousandths, 10 thousandths. This is 11 10,000ths. 0.0011. And the last one, negative 3.6 times 10 to the first, negative 3.6 times 10 to the first. We move our decimal 1 place to right here, so this becomes negative 36. The negative in front of the number just gets treated like normal. It doesn't mean to move left or move right. It just still has a negative in front. The negative on the power is what's indicating whether you should move left or move right. So bear in mind, if we are doing scientific notation, which way your positives and negatives move, and if you're transferring back to standard notation, which way your positives and negatives move. Good luck with the exercises, and please let me know if you have any questions.